Prove that if three parallel lines cut off equal segments on some transversal line, then they cut off equal segments on any other transversal line. So we have three parallel lines here. We have a transversal, the prefix trans means to cross, like think of transatlantic. And these three parallel lines cut off equal segments, so that this distance here, the distance from this point to this point, equals the distance of this point to this point. Then the three parallel lines will cut off equal segments on any other transversal line. So if we take any other transversal line, let's say we take this line here, what we want to prove is that the distance from here to here is equal to the distance from here to here. That this distance equals this distance. I use a double dash to distinguish it from this. It's not necessarily the same as this, of course. So if I call this distance A and this distance B, we have to prove that A is equal to B. Now the way we prove this is to use a construction. We draw a line that's parallel to this line. And then we draw a line that's parallel to this given transversal. This is what we were given at the start. So I've indicated these lines in yellow, and this blue arrow here indicates that this transversal is parallel to this line here. Now let's look at these two triangles formed. We notice that angle A equals angle B because they're opposite angles. We just have two lines crossing. Since these two lines are parallel, we have a pair of Z angles. See this Z-shaped here? Then these angles here, this is X, this is Y, are equal. They're known as Z angles or alternate angles. So I'm using capital letters here for angles. That's usually what's done. So two angles in these triangles are the same. A equals B, X equals Y. That means all three angles are the same. So you could mark in all three angles if you like. This angle here must equal this angle here. Actually, these two angles represented by the dot are Z angles because we have a Z shape here formed between these two parallel lines, Z or alternate angles. You could also say the three angles add up to 180. So if two of them are the same, the third one is automatically the same. Since this line here is parallel to this line here, we have opposite sides of a parallelogram. We have a parallelogram formed here. This is a parallelogram because this top side is also parallel to the bottom side because these two lines are parallel as well. So we have a four-sided figure where opposite sides are parallel. And when that's the situation, if opposite sides are parallel, then opposite sides are equal in length. So this distance here I'm calling C, and it must equal D. So I can just put a single dash on these. But if C equals D, then D must equal this side up here, this length here, because we're given that C is equal to E. That was given at the start. So C equals D and D equals E. So that means that, I'm sorry, D equals E was not given. C equals E was given. So C is equal to D and C is equal to E. That means D must equal E, because both D and E are equal to the same thing. They're both equal to C, which means that they're equal to each other. So what we've established now is that not only are these two triangles equiangular or similar, similar means the angles are the same, but one of the sides is the same as well. So we've proven that these two triangles are congruent. We can use the abbreviation ASA for angle sine angle. So for example, we have angle X side D and side dot equals angle Y side E and angle dot. That's angle side angle. When we have that situation for two triangles, then the two triangles are congruent or equal in every way. Now, in particular, that means that this distance here, this side of this triangle, must equal this side here of this triangle here. That's the side that's opposite the dot. Actually, I'll do that in the same color as the dot, just to emphasize that it corresponds to the dotted angle. So the sides opposite the dot are a pair of corresponding sides, and they must be equal for the triangles to be congruent. So I'll call this side of the triangle F, and this side here of this triangle G. So we've established that because the triangles are congruent, F must equal G. But now look, we go back out to this parallelogram, and we see that side F is opposite side A in this parallelogram. This is a parallelogram because this line is parallel to this line, and this line here is parallel to this line. And if opposite sides of a parallelogram are equal, so now we've established that F equals A, and similarly down here we have another parallelogram, so G must equal B. So I can put a double dash here to indicate that F equals A. Actually, I'll use purple color, and a double dash here to indicate that B equals G. But since F is equal to G, then A must equal B, because A is equal to F, B is equal to G. They're both equal to the same thing. A is equal to F, G is equal to B. So we could replace this G with F, for example. So both A and B are equal to the same thing. They're both equal to F. So that means that A is equal to B, and that's what we had to prove. So initially we were given some transversal that cuts through these three parallel lines with the property that this distance E equals the distance C. And then the idea was we have some other transversal, any other transversal. This one here stands for any other transversal. And we have to prove that this distance A equals B.